Hey guys, welcome back to 5.5 day 2. Hopefully yesterday's video was okay. You guys are getting spoiled 2 days in a row without homework. Um, so yesterday, it's a lot of confusing stuff, recalls a lot of ideas and concepts from Algebra 2. Basically, the point of that video was to know the restricted domains and ranges of our inverse function graphs, because without restricting them, they wouldn't be a function, right? Because it wouldn't pass the vertical line test. And so we need to know those restricted domains, okay? And so right here, we're really only going to talk about sine inverse, cosine inverse, and tangent inverse, or arcsine, arccosine, arctangent, and their restricted domains and ranges. And for today, what we're really going to focus on is the ranges of these inverse functions. So basically what that means is no matter what you plug in to arcsine, the sine inverse, you're going to get an answer between negative pi over 2 and pi over 2. If you converted that to degrees, that would be negative 90 to 90. Okay, so remember, sine inverse, you plug in a ratio and you get out your angle measure, whereas normal sine, you plug in the angle measure, you get out the ratio. Okay, and so it's backwards. So we're plugging in a ratio into sine inverse and you get out an angle measure. Same with cosine, except the range is from 0 degrees to pi, which is 180 degrees. So you're going to get an answer between 0 and 180 degrees. So it has to be an angle in between those. Okay? And then tangent, again, it's the same as sine. It's negative 90 to 90. And so that's the important thing to remember from yesterday's lesson. You're not going to be asked to graph these at all. Okay? Just understand why we had to. And, well, I'll get into it more in these examples. So this is going to be the majority of what we're doing is evaluating inverse functions. Okay? And so basically, oh, my pen. You're plugging in a ratio into these inverse functions, and you're getting out a degree measure. Now cosine, the range was in between 0 and 180 degrees. Okay, so it has to be between 0 and 180 degrees. Well, let's solve. So I usually rewrite these cosine and then of what angle equals 1/2. So we need to find cosine of what angle equals 1/2, because our answer is going to be that angle. And so it takes some skills from previous lessons and chapters. With cosine of 1/2, well, we need to know what cosine is. It's x over r, and so it's going to be positive. So it has to be between 0 and pi over 2, or sorry, 0 and pi, or 0 and 180. So it has to be in either quadrant 2 or quadrant 1. Well, since it's positive, it's going to have to be in quadrant 1, right? Because if it's in quadrant 2, the x value would be negative, so this would be negative. So we have to pay attention to that. So we know our r is going to be 2, and our x is going to be 1. Well, now we need to know, is there any special triangles that we know that would have those similar ratios? And if you recall 30, 60, 90, it's 1 square root of 3 and 2, right? So this would be the 30-degree angle, this would be the 60, and this would be the 90. So the angle measure that would get cosine of that angle measure equals 1/2 would be 60. So our angle would be 60. So cosine inverse of 1/2 equals 60 degrees. Now again, in the book, the answers might show out in radians, so you can convert easy by multiplying by pi over 180, and that would be pi over 3. So either of those answers would be acceptable. Okay. Now sine inverse of negative 1/2. So I'm going to draw my thing. Now remember, the range for this was restricted between negative 90 degrees and positive 90 degrees. Meaning negative 90 would be down here, positive 90 would be up here. So sine inverse would have to be in quadrant 1 or quadrant 4. Okay. And so, well, when would sine be negative? Well, remember, sine is y over r. Now sine wouldn't be negative over here, right? All students take calculus, all ratios will be positive in quadrant 1. That means it has to be in quadrant 4. Okay? And so, I'm going to draw my triangle. Very similar to last time. Our r is 2. This time, your y is negative 1. Remember, our r is never, our r is never negative, because that's basically our radius. And so if it's a negative value, I attach it to that top value. Well, then similarly, we look for the special triangles that we know, the 30, 60, 90, 45, 45, 90. And so this would have to be square root of 3. That's positive though, making this a 60-degree angle. This is going to be a 30, and that's our right angle. So, sine inverse of negative 1/2, what's the angle measure that gives us negative 1/2? Well, it's not 30. 30 would be right here, right? And so there's two ways you can think of it. Either negative 30 degrees, or you could think of it coterminal, add 360. If you go around 360, you're at 330. Now, this is probably what the book will tell you, negative 30 degrees, because your range, your answer has to be in between negative 90 degrees and 90 degrees. That's the sine inverse function only shoots out answers in between those two. Now there's something I want to talk about real quick. Sine inverse of negative 1/2. That could happen another time. Remember, all students take calculus. All students take calculus. So sine would also be negative in quadrant 3, right? If I draw this same triangle in quadrant 3, let's make the y value negative, let's make the x value negative, and this 2, so this would be a 30-degree angle again. Well, what is sine of this angle? Well, it would be negative 1 over 2. So technically there is another place where sine inverse, or sine would be equal to negative 1/2, and that would be, well, 90, 180 plus the 30. So at 210, sine of 210 also equals negative 1/2. But sine inverse doesn't equal 210, and that's because, remember, we had to restrict the domain of our sine function so that our inverse function was a function. Okay, because so it would pass the vertical line test. And so we're only going to talk about the values in the range. So technically there are more angles that would get the same ratio, but we're looking for the answer in the range. Okay? And so the correct answer would be negative 30 degrees. Now this is an interesting one. Sine inverse of negative 3/2. Well, first off, if you plug it in your calculator, remember to plug in inverse functions in your calculator. You do second and then the sine button. So second sine, let's type 3 divided by 2, error domain. Uh-oh. Well, do you remember the domain for sine? I'm going to lose these pictures. The domain for arcsine is -1 to 1, because on sine, the range, it shoots out answers between -1 and +1. And so in the domain for the arcsine, because they switch into sine inverse, only values of -1 to 1 can be plugged in. Well, 3 over 2 is greater than that. And so that's why we get a domain range. Also, another way to think about it, if we draw that triangle, sine inverse is between -90 and 90 degrees. Well, if it's positive, it has to be in quadrant 1, not quadrant 4. And so I'm going to draw this. So your R is 2, and your Y is 3. Well, if you recall some previous skills in geometry, a leg cannot be longer than the hypotenuse, right? And so that we don't even have a triangle there. The leg cannot be possible. The leg cannot possibly be longer than the hypotenuse. And so we're going to say undefined. Okay, that would be the answer there. Sorry about that. Well, cosine inverse of -1. Okay, and so we want to know what angle we plug in the cosine that would equal -1. And so first cosine inverse, the range 0 to 180 degrees. So it has to be in between 0 and 180 degrees. And so if it's a 0, 1, -1, it's probably going to be one of these values here. And so we need to test these 3. Well, so I write them out. This would be 1, 0. This would be 0, 1. And this would be -1, 0. Right? Just x values, unit circle. Okay. And remember, we don't really have triangles at these points, but the r at these points would be 1. So keep in mind the r would be 1 at any of these. So cosine. Well, cosine is x over r. So cosine at 0 would equal, well, x is 1, y is 1. That's +1. Nope, that's not our guy. Cosine at 90 would equal, well, 0 over 1, which is 0. Cosine at 180 would equal -1 over 1, which equals -1. Ding, 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 that's what we wanted. So cosine inverse of -1 equals the angle measure, 180 degrees. Okay. So you guys can check these for yourself. The purpose of this is so that you know, first off, you don't type sine to the -1 power. That's no. You don't do 1 divided by sine. You do second sine in your calculator. Okay, you type second sine, and that would bring up the sine with the -1 exponent there. And then you type in the value into parentheses. So I would type second sine -8 divided by 9, and you get about, except that's cosine. So second cosine -8 divided by 9, you get about 152.7 degrees. Okay. Second sine 0.12345. Get about 7. Tangent inverse, second tangent, of 1.53235 equals 56.87 about. Now obviously, hopefully we see these are degrees. If your calculator's in degree mode, it'll shoot out degrees. If it's in radian mode, it'll shoot out radians, okay? Last but not least, we're going to simplify trig functions. Now you'll see if you have two values, they almost cancel each other out. Two of the same value, one normal sign, one inverse sign, for instance, they almost cancel each other out. So sine, the way I do this is I work from the inside out, work in the stomach, the guts. So sine of 2 pi over 3. Okay, and so I want to evaluate that. And so we're probably still not comfortable if you with radians. If you have everything memorized in radians, that's great. Otherwise, let's convert 2 pi over 3 times 180 over pi to convert to degrees. Pi's cancel. 3 goes in 180 60 times. 2 times 60 is 120. So this is the same as sine of 120 degrees. So I'm going to draw my 120 degrees. And now we got to use our reference angle to solve. So this would be a 60-degree angle, which would make this square root of 3. This would be -1, and this would be 2. So sine of 120 degrees, well, square root of 3 over 2, right? So this right here equals square root of 3 over 2. So I'm going to plug in, instead of this right here, that equals square root of 3 over 2. Okay. Now, we have to find where sine inverse equals square root of 3 over 2. Now this one gets interesting because sine is restricted between -90 and 90 degrees. And so your answer would have to be in quadrant 1 or quadrant 4. So this right here looks like a good angle to choose, right? Your 120-degree angle got you square root of 3 over 2, except that's not in our range. Okay? And so we're going back to a degree. We started with this, which shot out our ratio, because you plug in degree into sine to get a ratio, and now we're plugging our ratio back into the inverse. Well, so it has to be in quadrant 1 because it's positive. So I'm going to draw my triangle. And we want the y to be square root of 3, the r to be 2. Well, that would have to make this a 60-degree angle. So this would equal a 60-degree angle right here. Okay? And so again, the answer in the book might be in radians. You can easily convert back. But it's just interesting how you get a ratio here for this inside guy, sine of 120, but then you get a different angle back out when you plug it back in, just because, remember, our inverses are restricted. Alright, let's do one final problem. Sorry, guys. So simplify expressions involving trig functions. So now we have to do the insides. So I always start with the insides. Sine inverse first. Okay. And so we want to know what angle we plug into sine to get square root of 3 over 2. So again, you need to know the domain. The domain for sine, again, is -90 to 90. So quadrant 1 or quadrant 4 is our two possibilities. It's positive, so we need to put it in quadrant 1. So our y value is square root of 3. Our x value is, our r is 2, which would make this have to be a 60-degree angle. Okay. So sine inverse of square root of 3 over 2 would be 60 degrees. So we have cosine of 2 times 60 degrees then? Well, which is 120. Cosine of 120. So now we have to evaluate cosine of 120. Well, you go over 90 and 30 more, so you have a 60-degree angle. Well, that means this has to be a 30. So look, it's our 30, 60, 90 triangle. This would be square root of 3. This would be -1. This would be 2. And so cosine at 120 degrees would be -1 over 2. And so that's the answer of this big guy simplified down. Okay, so just work step by step. Innards first. So hopefully this is okay for you guys. Let me know if you guys have questions about this. Just try your hardest, alright? And make sure you look at the HyperDoc to see if I changed the homework at all. But with that, I will see you guys tomorrow.